Hey Jeff, can you hand me that 10mm bolt?
No problem, Kate. All these bolts are a different size. 10 millimeters. Ah, here it is. Here you go, Kate.
Thanks, Jeff. Wait, what is this?
Well, it's that 10 millimeter bolt you asked for.
And how did you determine that?
Well, it's the one the 10 millimeter wrench fit.
You know, bolt size isn't determined by the head of the bolt.
I guess I don't really know that much about bolts.
Well, then I'm going to teach you about them and how to properly torque them while we're at it. A fastener is any item that's used to join two or more materials. This includes such things as adhesives, rivets, welds, plastic clips, and threaded fasteners. Threaded fasteners consist primarily of bolts and screws. Threaded fasteners come in many different designs. Some of the more common types include standard hex head, deep recess type, standard Torx, external or E-Torx, which require an E-Torx socket, and tamper-resistant Torx, which have a center stud and require a special Torx bit. Uniform bearing stress fasteners have an undercut around the shank on the underside of the head. Coated fasteners are used in some applications where the steel fastener is being threaded into a dissimilar metal such as aluminum. This coating prevents the two metals from corroding, which could cause the fastener to seize.
I've seen bolts in the parts catalog described by something like 8 by 80 or 10 by 70. What exactly does that mean?
A threaded fastener's size is determined by several aspects of its design. The first number in the description is the diameter of a fastener. It's determined by the outer diameter of the threads. As you can see, this is a 10mm fastener. The second number in the bolt description is the length. Length is determined by the distance from the end of the fastener to the base of the head. You can see that the fastener is 70 millimeters long. Therefore, this fastener is 10 by 70. Head size is simply the width of the head of the bolt from flat to flat. You can see this fastener has a 17mm head, but fasteners are never described by the head size. However, head size is also the tool size, so this bolt takes a 17mm wrench. Thread pitch is the distance from the top of one thread to the top of the next. Thread pitch can easily be measured using a thread pitch gauge. To measure the thread pitch, select the blade that exactly matches the threads on the fastener. Using a combination gauge is the easiest way to determine bolt size. This allows you to check the diameter, length, and thread pitch. Along with different designs and sizes, threaded fasteners vary by strength. These standard hex bolts may look similar, but they are very different in their construction. Fasteners fall into two classifications, standard and high tension, which are sometimes called hardened. Standard fasteners have no marking on their head or have a stamp reading 8.8 on the head. Bolts with an 8.8 on the head have greater strength than blank head bolts and must be replaced with bolts using the same markings. To ensure fasten joints stay tight, several types of locking devices are used. Several types of locking washers are commonly used, including star and split type. UBS fasteners are a locking type through their design. The slight bevel manufactured into the underside of the head causes the flange to flex as the fastener is tightened, providing additional friction to hold it tight. Self-locking nuts are also used to hold fasteners tight. By deforming the threads on the nut, extra clamping force against the bolt is provided. Cotter pins, used in conjunction with castle nuts, prevent the nut from turning. Cotter pins, used with standard hex nuts, won't prevent the nut from turning, but will prevent the nut from vibrating off the assembly if it works loose. Anytime a cotter pin is removed, discard the old pin and replace it with a new one. If you disassemble a threaded fastener that uses a locking device, always reassemble it using the exact type of locking device. Liquid thread lock, such as Honda lock, can also be used. The thread lock is applied before assembling the parts and cures once the parts are assembled. There are different strength grades of Honda lock available depending on the application. Honda lock should only be used when specified in the service information due to its effect on applied torque to the fastener, which we'll discuss later in the module. Due to their design, some fasteners can only be used once. Consult the service information to verify if a fastener can be reused or needs to be replaced with a new one. Reusing a one-time use fastener may cause it to work loose.
Hey, Kate, I don't understand why it's so important to torque fasteners anyway. I mean, tight is tight, isn't it?
Tight is tight? Are you kidding me? A lot of engineering goes into determining torque specification. When we apply torque to a fastener, we increase its clamping force on the objects being fastened. In order for that fastener to provide that clamping force, it has to stretch. It's this stretching that holds the parts tight like a very strong spring. Let's look at the relationship between clamping force and elongation or stretch. On the left, you have clamping force, and on the bottom you have elongation. You can see that as we apply torque, clamping force increases, and so does the amount the fastener is stretched. Since fasteners are designed to stretch, they act like a rubber band and return to their original size when the torque is released. It will act this way until it's tightened to the yield point. When the force applied to the fastener is below the yield point, it's in its elastic range. When tightened beyond the yield point, the fastener enters its plastic range and no longer returns to its original size when the torque is released. The fastener will remain permanently elongated. If you continue to tighten the fastener in the plastic range, it will begin to lose clamping force and will fail once it reaches its tensile point. Since fasteners need to stretch to provide clamping force, selecting the proper length fastener is critical. Due to the fastener's smaller diameter in the thread area, called the pitch diameter, most of the stretch takes place in the thread area when the fastener is torqued. This comes into play when selecting the length of a fastener. If too long a fastener is used, there may be enough thread to tighten it to the listed specification. However, the area where the majority of the fastener stretch takes place is dramatically smaller. For example, if we torque each bolt shown to the same specification, we stretch each bolt the same amount. But the longer bolt has less unengaged threads available to stretch. Therefore, each thread must stretch a greater amount. This applies more stress per thread to the fastener, which may shorten its service life. To be certain you select the proper size fastener, check the service information for the fastener's diameter and thread pitch.
Now I get it. If we don't tighten the fastener enough, it may work loose. But if we tighten it too much, we might exceed the yield point and permanently stretch or even break the fastener.
You got it, Jeff, but there's still more to learn about torque. Tools for torquing fasteners come in many shapes and sizes. Some of the most popular include click, dial, beam, and electronic torque wrenches for general purpose use. For low torque value applications, such as TPMS sensor installation, torque screwdrivers can be used. Some applications call for a fastener to be tightened by a certain degree of rotation. For that, a torque angle gauge is required. This will be discussed in more detail later in the module. When selecting the proper torque wrench, for more accuracy, select one so that the torque you are applying falls somewhere in the middle of the usable range of the tool rather than at either end of its usable range. For example, if you need to torque a fastener to 50 pounds-feet, then the better torque wrench for this would be the one with a 30 to 150 foot-pound range. Using a torque wrench at either end of its usable range is not as accurate as ranges in between. When torquing fasteners, there are a few things you need to remember. If you're torquing a fastener and you immediately reach the desired torque, it may already be over-tightened. Loosen the fastener with a tool other than the torque wrench and re-torque it. Final torque must be reached while the fastener is still turning. If the fastener stops moving before it is fully seated against the clamping surface, it must be loosened and re-torqued. The fastener may be binding, cross-threaded, or have dirt in the threads. If multiple fasteners on one component, such as an oil pan, are being torqued, torque them in the proper pattern to half of the specified torque rating. Then come back and start the sequence over, torquing them to the full specification. This ensures that the torque will be evenly distributed to the entire component. If no pattern is specified, such as on this water pump, tighten the fasteners in a crisscross pattern, starting in the middle and working your way outward. Some fasteners, such as those used in cylinder heads, require that they be torqued to a specified value which is lower than the final torque. When required to do so, always use a torque angle gauge to ensure accurate rotation. To use the torque angle gauge, attach the correct socket to the bottom of the gauge and a ratchet or breaker bar to the top. Hold the arm assembly to prevent it from turning and tighten the bolt until you reach the desired angle of rotation. When working with these types of fasteners, always follow the service information to see if the fastener can be reused. Some repairs will require you to adjust rotating components to a specified starting torque. To do this, rotate the component you are measuring several times to seat the bearings. Then, using an inch-pound, beam, or dial-type torque wrench, begin to apply pressure to rotate the nut. Take note of how much torque is used before the nut begins to move. The amount of torque it takes to rotate the nut is the starting torque. Fasteners are designed to be installed clean and dry unless specified in the service information. Lubrication can have a drastic effect on torquing fasteners. When a fastener is torqued, approximately 50% of the torque is used to overcome the friction of the head or flange, 40% is used to overcome the friction of the threads, and only 10% is used to actually stretch the bolt and create clamping force. But let's say, for example, we were to lubricate the threads of this fastener and the service information did not call for it. 50% of the torque would still be used at the flange, but because the friction between the threads has been reduced, only 20% of the torque would be used there. That would leave 30% of the torque to be used to stretch the fastener. So even though we would have torqued the fastener to proper specification, we would have over-tightened it and possibly stretched the fastener into its plastic range, which could lead to a failure. By the same token, some fasteners are designed to be installed lubricated. Do not install this type dry or you'll under-tighten the fastener, possibly causing it to work loose. When using any tool that attaches to a torque wrench, keep in mind that some attachments will affect the amount of torque applied to the fastener. Straight extensions that extend 90 degrees to the torque wrench will not affect the applied torque. The extension may flex slightly, causing the wrench to turn further than a wrench without an extension, but the torque applied to the fastener will be the same. Any extension that increases the overall length of the tool, such as a crow's foot, will affect the applied torque and should not be used unless directed by the service information. Also, while they may come in handy to reach tight places, U-joint attachments should never be used with a torque wrench. They'll affect the applied torque and cause you to improperly torque the fastener. You may run into situations where fasteners are damaged and require repair or replacement. A few reasons for this are cross-threaded fasteners, over-torqued fasteners, the wrong fastener being used, the fastener is corroded, or it failed due to outside influences such as a collision. If the fastener is reusable, there are a couple of things to note when determining the condition of the threads on a fastener. Never install a dirty threaded fastener. The dirt will increase the friction between the threads and cause the fastener to be mistorqued. If the threads are dirty, use solvent, a wire brush or wheel, or a thread chaser to clean the threads. Do not confuse a thread chaser for a thread die. Chasers are used for cleaning threads. Dies are used to cut new threads on a length of straight rod. Using a die on a threaded fastener will remove material from the threads and weaken the fastener. If you need to clean a coated bolt, take care not to remove any of the coating, as this may result in corrosion. If this occurs, replace the fastener. If the threads are damaged, replace the fastener. Do not attempt to repair the threads. When replacing a fastener, always use the service information and/or parts catalog to make sure you use the exact fastener the component is engineered for. Occasionally, you may need to remove a broken fastener. Several tools are available to aid you in doing so. Stud removal tools, left-hand drill bits, and extractor tools can all be used depending on the condition of the fastener. If the broken fastener you are trying to remove has enough shank exposed, then try a cam-type stud extractor to remove it. Place the broken fastener through the hole on the tool, and using a ratchet or breaker bar, turn the tool in the direction the fastener needs to be backed out. This will cause the cam to tighten against the fastener and then allow you to back the fastener out. If the fastener breaks off too short to grip it with a stud extractor, a technique you can use is to grind the shank flat and use a center punch to mark the center of the fastener. Then, after drilling a small pilot hole, select a left-handed drill bit of a smaller diameter than the fastener, and remembering to reverse the direction of your drill, drill out the fastener. If you're drilling out a hardened fastener, be sure to use a hardened drill bit. The drill bit, turning counterclockwise, may be enough to extract it. If not, use a threaded extractor tool to back the fastener out. To do this, thread the tool counterclockwise into the hole until it's tight. Continue turning the tool until the fastener is removed. If the fastener cannot be removed, or the threads on the component have been damaged, the component will either need to be replaced or a time cert will need to be used. Time cert kits are available in various sizes, allowing you to repair a damaged threaded hole and use the original threaded fastener. This repair method removes the old threads from the component and permanently creates new ones. The procedure will vary depending on the location of the threaded hole you need to replace. For most time cert repairs, first lubricate and drill out the damaged threaded hole with the supplied drill bit, keeping it square to the drilling surface. Next, using the supplied bit, lubricate and counterbore the hole. This provides a shoulder for the time cert to sit in, creating a flush component mounting surface. Then, lubricate the supplied tap and thread it into the hole, cutting the threads for the time cert to thread into. With the hole tapped, the time cert can now be installed. Lubricate the end of the installation driver and thread the time cert onto it. Then thread the time cert into the hole you tapped. Once the time cert is fully seated, more resistance is needed to turn the installation driver. That resistance is the driver permanently seating the time cert into the hole. Continue turning the driver until the resistance is gone and it's again easy to turn. The time cert is now seated into the threaded hole. For more information on time certs, visit the website at the link shown here. So, when working with threaded fasteners, I can't stress these points enough. Always check the service information to ensure you are using the correct fastener. Make sure that the threads are clean and dry, and only lubricate the fastener if the service information directs you to. Always torque fasteners to their listed service specification. If the fastener stops moving before it is fully seated against the clamping surface, it must be loosened and retorqued. The fastener may be binding, cross-threaded, or have dirt in the threads. Always replace damaged fasteners. Do not attempt to repair them. And replace the component or use a time cert for the repair if the threaded hole is damaged.